So starting off with the battery build, I've been using recycled 18650 batteries or cells. These are from a scooter battery or an e-bike battery, I'm not sure where it is. And what I tend to do is take off the nickel connections using a diagonal cutter. So quite difficult one-handed. Taking them all off, and then what I'll do is I'll grind down the ends using a Dremel, a light touch on the Dremel, just so that I don't pierce the batteries itself. What also happens next is here you take off the spacer from the cell, and each of these cells will be tested using a 18650 tester. So I'll cycle through. Each cell here is 2500, and then obviously I'll get the capacity rating for each of them, and then I'll reorganize each pack using a tool online called SALVAGE, and that will give me the outputs in terms of my parallel banks. So what you can see here is me using a insulation thing that will protect the top positive end from short circuit. So I'm just double checking everything, making sure that each of them are all insulated very well, and then here just putting on the other side of the cell spacers. The cells that I'm making here are 10S 10P, and there'll be two sets of these to make a 72 volt, which is a 20S 10P, which should give me about 55 milliamp of battery.
We're going to start welding the battery. There's a couple of things that are a bit weird and not ideal, to be honest. So what we've got here is, in the next sort of image I'll show you, we've got two battery banks, so 10P, so 10S 20P, times that by 2, so you've got 20S 20P, which gives us a total, I think, capacity around 55 amp hours. Pretty hefty battery. I think the total weight already is around about 20 kilos, just in batteries alone. So what I've done is I've taken some ladder nickel, you can see here, and what I've done is cut it to length, cut an extra bit as a rectangle here for a tab that I can solder onto the balance leads. And then what I'll be planning to do is basically start welding using a spot welder. The issue that I've run into with this particular strip and the spacers that I have is, if I let me just grab one. So these are the spacers that I've been using from AliExpress, and this is a nickel strip that I picked up from Fogstar wholesale in the UK. The main issue is the fact that the spacing on the nickel doesn't match up to the spacing on the actual battery spacers. I've asked Fogstar if they have something that matches. They also don't have something that matches their own product, which is a bit weird. You'd expect at least one wholesaler to have nickel that matches the spacers itself. So what you can see here, for example, is this is a spacer. If I try to align the middle squares, so I've aligned the first one, the second one doesn't really align, the third one is even worse, and it gets worse and worse progressively, which is sort of raising a bit of issues in terms of our welding. So I've started doing I've done a half weld on a parallel series, so let me show you that. bit of an issue. So connecting up the cells in parallel and series, and going through the second half of the pack, and one of the cells started degassing. So that basically means that I need to strip back the whole side to remove that cell. So what I mean by degassing, basically it started bubbling, releasing the, I guess, hydrogen gas that's inside between the chemistry, and it's running at 4.6 volts, which obviously is a lot higher than what it should be, which is 4.2 volts. So I'm going to have to strip back the one side, take off the battery holders, just to remove that one cell, and spend more time wasted on re-welding that side back. So yeah, so I guess that's one of the issues with using salvage cells. I think what must have happened is all the other cells are running at 4.1 volts. This must have been running a bit higher, and also when you connect cells up in parallel, the cells will balance out in terms of voltage, and this must have been a bit higher or something, but now currently running at 4.6, which is completely unsafe, so you need to do that now.
That's it for part 1. In the next video we're going to be adding the BMS, waterproofing it, and making sure it's ready for its first charge. And after that we're going to make a battery case. So catch you guys in the next video.